MTD CNC, bringing you the latest engineering news via video media.
Alan, this machine behind us has been launched this year. It's launched at EMO.
Yes.
It's about additive manufacturing in the main. It's been a lot of attention on this machine today. Give us an idea of what the machine actually does.
Well, this is really an extension of our multitasking capability. Mazak is synonymous with the word of multitasking and the INTEGREX. What we've developed is really an extension to that, adding now the ability to add material, dissimilar materials in many cases, to a main substrate. And where we see this really as a focus is industries such as repair, for relifing parts of value, for cladding of dissimilar metals onto substrates, and to adding features to parts in order to reduce the cost. And typically you find in aerospace the buy to fly ratio being so important, and how we can reduce the amount of material we're having to take away by adding on those parts which are most critically important.
So this machine here is a machine that has got turning and milling function, but further to that you can add material to a component.
Correct, yeah. We've really developed the INTEGREX, which has full 5-axis machining capability, and now added the ability not only to machine in 5-axis, but to clad in 4-axis on the C-axis side, and with the benefit now of the U and V axis, provide both 5-axis cladding and 5-axis machining. So a real done-in-one product.
It's a pretty sophisticated machine, but when we talk about additive manufacturing, 3D printing, are they the same or different?
No, I think it's you have to be very careful when you're talking about the umbrella of 3D printing. The technology we're using is what's called direct energy deposition. So we're blowing a powder, in this case Inconel 718, into a heat source, in our case a laser, a 1 kilowatt laser, and effectively melting that within an argon gas shielded area. So it's very different to the powder bed systems you see from various other companies, which is using a laser to scan into a bed of powder. We're actually blowing the powder onto the substrate and melting it in a typical welding process.
And what sort of thickness or dimensionally is what you're actually adding to the material?
The example we're showing here with the two heads is either 3 millimeters in bead width by 1.5 millimeters in height, which is a high rate head, or 1 millimeter in width and 0.5 millimeter in height. And the reason we have the two is for the two different application types. The high rate head is for heavy duty cladding, putting a lot of material down very quickly. And the fine rate head is for detailing parts which are perhaps more resolution required and therefore will require less machining to get to a net shape.
And those two heads, is that pretty unique to Mazak? Because there are other machines with the mill turn and the additive manufacturing on them.
Yeah, we offer the ability with the INTEGREX to effectively use multiple heads. And those heads are stored within the standard machine tool changer. So whilst we're showing two today, that could be as many as the tool changer capacity is. So the opportunities are potentially boundless, but clearly it's based on application in terms of the head functionality we offer.
And we spoke, or you mentioned about 5-axis additive manufacturing. The head doesn't move on this, but the kind of C-axis does, so it enables you to do that.
Yeah, on the machine we're showing here, we're offering both two work areas. On the left-hand side, the standard C-axis, where you have 4 axes of motion. And on the right-hand side, because we're using the U and V axis, which is a tilt and rotary table, we can offer full 5 axis of motion, 2 of which are in the actual part itself, and then 3 in the head.
Let's go back to the type of user of this, because it's not going to be for everyone.
No.
But where do you see it fitting? Give us another example of component.
As I say, we really see this fitting into 3 main categories of area. One is where we're adding dissimilar materials to a substrate where you want dissimilar properties. For example, stabilizers on oil and gas applications where you want a hard metal on a relatively soft substrate. Secondly, where you
How would you do that now? Would you have to make the whole part out of the hard metal?
In this case, no, you'd have to separate the process. So you clad on a separate machine, thermal spray, and then re-enter that part into a machining center or turning center and finish the process. So here we're doing all of that in one. The second area, which we think is also very important, is relifing of high-value components. So where you can take a component, remove the area which is now either worn or damaged, reclad back to a near net shape, and then machine back to the net shape, and therefore relifing the component.
Where do you see this in 2 years' time?
Good question. The technology is clearly developing at a high rate, and what will drive that are the applications that our customers will bring to us. So it's not easy to say exactly where the technology will be, but certainly along with the innovation that we've brought to the multitasking world, it will develop in terms of both the metallurgy, the powder, the axis configuration, but most notably I think the applications that now start to utilise the benefits of hybrid manufacturing.
It's an education, isn't it? To me, I look at this, I've learned a lot today, and I think it's important for people to explore this. Are Mazak at the forefront?
We believe we are in hybrid, yes. We've stayed at the front in terms of multitasking INTEGREX products, and we clearly see this, as I mentioned earlier, as an extension to that multitasking capability, which really is driving innovation both on the machine side, but also making our customers think about the applications they can now introduce into their manufacturing process.
Alan, thanks for your time.
Pleasure.